Okay, guys, so sorry I'm not there today, but we are going to take some notes, and I wanted you to still get a lecture so we're not wasting time and doing busy work. Um, so this is a short section of notes. It starts on page 19 of your packet, but it's pretty complex. So if you remember, you probably learned this in elementary school. Warm air rises and cooler air sinks. Also, warm air is more dense and cooler air is less dense. That's why when you go to higher altitudes, they say that the air is thin. It truly is. There's less molecules there. There's less density. Um, Sorry, I have a visitor from my daughter. Okay. Never a dull moment at my house. So, next. All right. So, this is also why hotter climates a lot of times are associated with humidity because warm air expands and can hold more moisture. Of course, the saturation point is when the air is full of moisture, and that's why it's a percentage, and that's why our relative humidity where we live in Florida is always very high, and all the ladies have bad hair days um, because we hover very close to that saturation point. And then, of course, when we go a little bit over it, that's when you have precipitation. All right, adiabatic heating and cooling. This occurs commonly in the mountains, but this is when air masses rise because of the differences in pressure and then also sink. But when air masses rise, they expand. When they expand, they are able to cool. This is also why in the mountains, a lot of times you'll have a storm pop up, but it dissipates relatively fast because as that air mass rises up the mountain, it starts to expand, it starts to cool, and it starts to run out of energy. Um, and that's also why a lot of times you have worse storms at sea level because you've got more pressure, um, more humidity, and all of those factors. So, alone, each of these factors are pretty simple, but you put them all together, and that's why meteorology is so complex and so interesting to me. All right, if you remember back in elementary school and even in eighth grade when we talk about phase changes, um, latent heat is the energy released when the water vapor, which is of course the gas, turns into liquid. It's very exothermic and it releases energy as it does that. And then of course if it went the other way, it would take in energy. So that heat being released goes into the environment and also affects our weather. Okay, so if you put it all together, here's kind of all the four factors that affect our air circulation patterns. So you see the pressure, you see the energy, and you see this is like a cycle. So what we get with all these air circulation patterns, cells. So if you look, you've got, I'm gonna try to write for you. Um, you've got these cells over here that are happening, and you can see. So the warmer air rises, and then it cools, and then it sinks back down. And of course, the energy that is driving all of that is the sun, the energy that comes to us from the sun. And so here are those cells. Here are the names of those cells. So the Hadley cell, the Farrell cell, the polar cell, and then they repeat. So you've got down here, this is also a Hadley cell and Farrell cell. And so this is what's happening with all of those four factors working together. And this moves these air masses around our Earth. Deserts are typically created by high pressure and sinking air, and that's why they're drier because it's higher pressure. And then, of course, the tropical rainforests, you know, are more. Okay, but those are those wind patterns. These are three links that will also help explain. I'm sure they're much better quality than this video, But be sure to watch these. I linked them in the Canvas assignment at the bottom, so you'll be able to click on these and watch these as well. And that's it for this section. Thanks so much, guys.